Assalamu alaikum warahmatullah. Hello my dear students. Today inshallah we're gonna start in unit 1, lesson 1, which is talking about the oscillatory motion. The types of motions are transitional motion and periodic motion. Periodic motion, it is the motion which is regularly repeated in equal periods of times. Examples of periodic motion like oscillatory motion and wave motion. Oscillatory motion like the motion of pendulum, and wave motion like the motion of water. Oscillatory motion, it is the motion of the oscillating body around its rest point, where the motion is repeated through equal intervals of time, like we see here in this image. The pendulum moves around its rest point. Okay. Relation between the velocity of an oscillating body and its kinetic energy, we can calculate it from this law, which is kinetic energy equal half mass times velocity power 2. Examples of oscillatory motion like the motion of pendulum, motion of or the vibration of tuning fork, spring, motion of swing, and stretched string. Okay. Now we have here an important note. The motion of the rotary bee is considered as a periodic motion, not oscillatory motion, because it doesn't repeat it around a fixed point, okay, like in oscillatory motion. The graphical representation of oscillatory motion will be like this from the following graph. Properties of the oscillatory motion. Oscillatory motion expressed in many concepts like amplitude, complete oscillation, periodic time, and frequency. Let's see these definitions. Number 1, amplitude. It is the maximum displacement done by the oscillating body. Like if we see here in this image, the pendulum moves away from its rest point to a maximum displacement. This maximum displacement called by amplitude. Complete oscillation, it is the movement made by the oscillating body when it passes a single point in its path of motion two consecutive times in the same direction. Like we see here in the motion of the pendulum, it moves around its rest position, okay, two consecutive times or two successive times. This motion is called complete oscillation. Like if we see here in this image, the motion of pendulum from point C to point A, then to point B, then it back from B to A, and from A to C. This is called complete oscillation. Periodic time, it is the time needed by an oscillating body to make a complete oscillation. And we can calculate it from this law. Periodic time equal time in seconds over number of complete oscillations. Frequency, it is the number of complete oscillations in 1 second. The unit of frequency is Hertz. Frequency can be calculated from this law, number of complete vibrations over time. As if we notice here, the law of frequency is the opposite of the law of periodic time. So we can calculate frequency from another law, which is frequency equal 1 over periodic time. Relation between frequency and periodic time can be measured or calculated from this law, frequency equals 1 over periodic time. Relation between periodic time and the time of amplitude. Periodic time equals 4 times the time of amplitude. Time of amplitude equals quarter the periodic time.